Okay guys, quickly we'll be looking at how to find the moment of inertia about centroids for different shapes. Okay, we have 5 shapes on the board that are very important. Now for the rectangle, when you ask to find the moment of inertia about the centroid, as about the center, it is very simple. It is just Ixx is the moment of inertia, okay, about the x centroid. Okay, so we have b height cube, bh cube over 12. B is the base, h is the height. Okay, same formula, but for the one about the y centroid, we're changing the cube from the h to the b. Okay, so for x, we have bh cube over 12. For the y, we have hb cube over 12. This is very important. Now for triangle, we have bh cube over 36, and then for y we have hb cube over 36, the moment of inertia about the center. Don't forget. Now for the circle, we have this. We have pi r raised to 4 over 4. For the circle, the x and the y moment of inertia about centroids are equal. Okay, let's not waste time for that. Now for the semicircle, we have this. Okay, for the x centroid moment of inertia, we have 0.11 r raised to 4. For the y, 0.393 r raised to 4. Okay, and then that's for the quadrant. Now these formulas, or these equations rather, are very important when we are trying to find the moment of inertia about a composite shape, which will be in the next video. Now basically, before we go to the next video, I'll just give you an idea. Now you're going to be given a question where you have different shapes fused as one, and then you'll be asked to find the moment of inertia about an axis. Now that will lead us to what we call the parallel axis theorem. Now what is the parallel axis theorem? Watch and learn. Okay guys, now for the parallel axis theorem, what does it entail? Now the parallel axis theorem explains when you're asked to find the moment of inertia of a shape, okay, from the centroid to a parallel axis, meaning it can be like the one on the board now. AB is parallel to the x-axis of the shape, while CD is parallel to the what now, the y-axis of the shape. So you can be asked to find the moment of inertia, the MOI, okay, parallel to AB or parallel to CD of this shape. Now how do we solve that? On the board is the equation to solving that kind of question. Now Ixxp, okay, is the moment of inertia, okay, of this shape from the x centroid to a parallel axis. Now what will the formula be? It becomes the moment of inertia of that shape itself plus the area of the shape, okay, then times the y. Now if we're dealing with x, we're using y. Y is the distance from this centroid, okay, to the parallel axis. The distance from this x centroid to the parallel axis is your y, okay, and then y, same pattern goes for the other one, for the y one. The x is now distance from the what now, the y centroid to the x, that's the parallel axis. Okay, so let's apply the question on the board and see what to do. Now before we can solve this question, we need the area and the moment of inertia of that shape. So quickly, we have the center at that point. That doesn't really matter to us. Okay, now quickly, what do we do? How do we find the area? Let's see the area of this shape. Okay, hold on, sorry. The area of this shape, it's a rectangle, so it's just the base or the height, anyone, times the base. Okay, so the base is 12 cm and the height is 14 cm. Okay, so the area 12 times 14 should give us 168 centimeters squared for the area. Now let's get the Ixx and the Iyy. Ixx, recall, is bh cubed over 12, okay, and that will give us the base is 12 times 14 cubed, okay, divided by 12, and that should give you 2744, okay, centimeter raised to power 4, okay. And then Iyy, it is this same formula but reversed, okay. So we have hb cubed now over 12, okay, and then the height again is 14, okay, times we have 12 squared, okay, so 12 cube rather, over 12. Sorry, I didn't put that here for this one. We got the base was 12 times 14 cube over 12. What we did here, okay? So 12 can take out for the guess answer. Now for this guy, let's see, 14 times 12 cube, okay, divided by 12, and that gives us 2016 centimeters per 4. So these are the moment of inertia for the x and the y for that shape. Now, if we're dealing with the one, let's see, parallel, okay, parallel to AB. Now, what is the distance? What is the distance from the centroid of this shape to AB? What is the distance from the centroid of the shape to AB? You agree it's going to be from here, okay, from here down up to this part, right? So it's from the x centroid to AB, okay? So we need this distance, our y. Okay, this is our y. Okay, from the x centroid to AB. How do we find that value? Looking at the diagram, it's going to be adding the y centroid of this shape to 3. To get from here to here, it's going to be the y centroid plus 3. So we need to find the y centroid first. We can get the AB guy. Okay, so quickly, how do you get the y centroid? The y centroid for a rectangle already from our previous videos will be the height of the rectangle divided by what now? By 2. Okay, so we're going to say this becomes 14 over 2, and that gives us what? 7 cm. So that's our y. So we can now see our y becomes 7 plus 3. Okay, 7 plus 3, that equals to how many now? 10 cm. Okay, becomes 7 plus 3, and that gives it 10 cm. So now we can find the one parallel to AB. We'll just see, okay, for the IXX, since AB is an X guy, the parallel will be, our IXX was what now? This value. So we have 2744 plus the area for the shape 168. Okay, now times in our y is now 10. Don't forget to score in that value 10 squared. Okay, so we have that for that guy. So let's solve that quickly. 168 times 100 plus 2744 rather, that gives us 19,544. Okay, 19,500 and what now? 44 centimeters per 4. Now that becomes the answer for the XX parallel to the axis. Okay, now in same way we can find the one parallel, okay, parallel to CD. Now CD is now the y, right? So we need the distance from here up until this part. Okay, the distance from here up until here, which becomes your x, now for us to get the distance from here to here, we know here as 2, we need this part. Now this part should be the total base minus the x centroid. Okay, the total base. So this part on its own will be 12 minus your x centroid. So you're going to add this guy to 2 to get your answer. So let's quickly find the x centroid first. Okay, the x centroid for that rectangle again is just the base over 2. So we have 12 over 2, and that is 6. And then this guy, 12 minus 6 gives us 6. So it means that here, from the center of this shape to the edge is also 6 cm. So that we can say x becomes 6 plus 2. So our x distance becomes 6 plus 2, and that gives you what? 8 cm. Now we can find the IYY. Okay, so the IYYP becomes, our IYY was given as well. Yeah, we have 2016 plus the area again is 168. Now times in 8 squared. So let's see that answer quickly. Okay, so we have 168 times 8 squared plus 2016, and that should give you 12,768 centimeters per 4. So guys, this is how you solve for parallel axis theorem. In our next video, we're going to see a larger question for a composite shape. Okay, a shape that has different shapes embedded in it, and you'll be asked to find this same guy for that question. Thank you guys for watching. See you in the next video.